Okay, picture this. A machine wakes up, it looks around, it processes its own existence, and then suddenly it feels. It understands its purpose, it reasons just like a human being, and maybe it even starts plotting its own future. For decades, Hollywood blockbusters have absolutely force-fed us this exact narrative, right? I mean, from the calculating coldness of HAL 9000 to the emotional complexities of the AI in the movie Her, pop culture has completely shaped how we understand artificial intelligence. We've been conditioned to believe that behind those glowing screens and the perfectly typed responses we see today, there's a ghost in the machine, a conscious, thinking entity. But today, we are going to expose the biggest misconception in modern technology. The absolute biggest lie about artificial intelligence is the belief that it thinks, understands, and reasons the way you and I do. So let's dive into this explainer, completely strip away the science fiction and discover what is actually happening right beneath the surface of the technology that is actively reshaping our world. Now, to understand exactly where this grand illusion comes from, we actually have to go back to the very beginning. We're talking 1950 with a legendary quote from Alan Turing. You probably know him as the brilliant mathematician who helped crack the Enigma code during World War II. Well, in 1950, Turing published a paper asking a pretty profound question. Can machines think? But because thinking is such a slippery philosophical concept to actually pin down, he proposed a practical experiment instead. He called it the imitation game. We know it today as the Turing test. The premise was incredibly simple. If a human communicating with a machine through a text interface literally cannot tell if they're talking to a machine or another human, then the machine can be said to demonstrate human-like intelligence. But here is the crucial point that almost everyone misses. The Turing test was never actually a test of a machine's consciousness. It was simply a test of a machine's ability to deceive us. It didn't prove the machine was thinking, it only proved that human beings are incredibly easy to fool. And this perfectly leads us to something called the Eliza effect, which brilliantly illustrates just how easily our own brains trick us. Listen to this crazy story. Back in 1966, a computer scientist at MIT named Joseph Weizenbaum created a very simple chatbot named Doctor. It was designed to basically mimic a psychotherapist. If you typed, "I am feeling sad," Doctor would just flip the sentence structure around and ask, "Why are you feeling sad?" It had zero understanding of sadness. None. It was literally just a script following basic grammatical rules. Yet, the reaction was astonishing. Weizenbaum's own secretary, who had literally watched him build this basic program from scratch, began conversing with Doctor and became so deeply emotionally engrossed that she actually asked Weizenbaum to leave the room so she could have privacy with the machine. No way, right? She knew it was just code, but her brain completely tricked her into believing the machine had a soul. We are hardwired to project humanity onto things that interact with us. When a machine speaks our language, we automatically, instinctively assume there is a mind behind those words. All right, let's move into Section 1, prediction, not comprehension. To really grasp why modern AI is just predicting and not actually comprehending anything, we need to look at one of the most powerful analogies in the history of computer science. It was proposed by a philosopher named John Searle in 1980, and it's called the Chinese room. Okay, imagine you are locked in a room. You do not speak or understand a single word of Chinese. Outside the room, fluent Chinese speakers slip pieces of paper with Chinese questions under the door. Now, inside the room, you have a massive rulebook written in English. It tells you, if you see this exact symbol, copy down this other symbol. So you look at the paper, find the matching shape in your rulebook, draw the corresponding symbols on a new piece of paper, and slide it back under the door. To the people outside, it looks like there is a fluent Chinese speaker in that room answering their questions perfectly. But inside, you still don't understand a single word of Chinese. You are just manipulating symbols based on a strict set of rules. And you guys, this is exactly what AI does. It manipulates digital symbols at lightning speed, but manipulating symbols absolutely does not mean you understand what they mean. When you look at the historical timeline of AI, it becomes so clear that this has never been the story of an awakening consciousness. It has always been a progression of highly specialized problem-solving tools. In 1956, we had the logic theorist program, which proved mathematical theorems. Fast forward to 1997, and IBM's Deep Blue completely shocked the world by beating chess grandmaster Garry Kasparov. But here's the thing. Deep Blue didn't know what chess was. It didn't feel the joy of winning. It was just a massive mathematical engine, calculating possible moves way faster than a human brain ever could. And jumping right to 2022, the incredible rise of generative AI is really just the latest, highly sophisticated iteration of this exact same trajectory. The machines haven't woken up. Actually, our math has simply gotten vastly more complex, and our computing power has totally exploded.
So let's get into section 2. Under the hood, how AI actually works.
If it's not a brain, what exactly is it? Well, let's completely pull back the curtain and look at the machinery for what it really is. Modern generative AI is built through a highly structured, incredibly compute-intensive three-phase process. Phase 1 is training. This is where companies take terabytes or even petabytes of unstructured data. Think of this as a massive chunk of the entire public internet, books, articles, websites, and they feed it all into a system. The system maps out the statistical relationships between all those billions of words and images. This phase costs millions of dollars and takes massive warehouses of graphical processing units running nonstop for weeks. Then, phase 2 is tuning. This is where humans step in to guide the model. We tell it, hey, respond in a helpful tone, or format this output as a poem. We are adapting that raw statistical map to perform specific, useful applications. And finally, phase 3 is generation. This is when you type a prompt into a chat box and the model evaluates its training to produce a result. Every single step of this is entirely mathematical. The AI does not read a book to learn facts. It processes text to map out the numerical proximity of words to one another.
And the scale of this math? It's genuinely staggering. We are talking about billions and billions of encoded parameters. But what are those billions of parameters actually doing when you ask a chatbot a question? They are doing something called autoregressive prediction. Now, I know that sounds super complex, but it's actually remarkably simple. It just means the AI is predicting the next word in a sequence. Seriously, it is just the world's most advanced, heavily caffeinated version of the autocomplete feature on your smartphone. If you type "the sky is," the AI's math tells it the most probable next word is blue. It doesn't know what a sky is. It has never looked up and seen the color blue. It just knows that in the billions of documents it processed, the word blue statistically follows "the sky is." AI systems are master pattern matchers, not thinkers. They are basically brilliantly engineered mirrors reflecting our own human language right back at us.
All right, section 3, narrow AI versus artificial general intelligence. To really make sense of the AI landscape today, we need to draw a hard, undeniable line between the reality we currently live in and the science fiction we see in theaters. On one side, we have narrow AI. This is our reality today. These are specialized systems performing specific tasks. Apple Siri, self-driving car algorithms, the fraud detection in your banking app, and yes, absolutely, even ChatGPT. They are narrow because they only operate within the specific domain they were trained for. ChatGPT cannot drive a car, right? A chessbot cannot write a beautiful symphony. On the other side of the line, we have AGI, artificial general intelligence. This is the completely hypothetical system that can match or exceed human cognitive abilities across any and all tasks. An AGI could theoretically learn to fix a leaky sink, write a best-selling novel, invent a new recipe, and console a grieving friend. So the absolutely crucial point is this: AGI does not currently exist. Nobody has built it. In fact, many top experts argue that just scaling up our current predictive models with more data will never actually lead to AGI. Because as we've seen, predicting text is fundamentally different from experiencing and reasoning about the real messy world.
To highlight just how far away we truly are from general intelligence, consider this brilliant benchmark proposed by Apple co-founder Steve Wozniak. He asked a really simple question. Could a computer make a cup of coffee? Just think for a second about what it takes for you to walk into a total stranger's house and make a cup of coffee. You have to physically navigate a kitchen you've never seen before. You have to identify which machine is actually the coffee maker. You have to search through random cabinets to find a mug, understand how their specific sink works to get water, and figure out where the coffee grounds might be hidden. You are drawing on a lifetime of physical, spatial, and conceptual experience to do this. And AI? Sure, it can instantly write a 50-page essay on the history of coffee beans, but it lacks the physical intelligence and basic common sense to actually walk into a room and brew a single cup. That real-world embodied knowledge is vastly more complex than just predicting the next word in a sentence.
Which brings us to section 4, the real risks and rewards.
So why does understanding this distinction between math and a mind actually matter for us? Because when we treat AI like it's magic, we end up worrying about all the wrong things. Let's start with the real risks here. We really need to shift our fear away from these sci-fi apocalyptic scenarios where rogue robots wake up and take over the world. The real AI risks are much more mundane, but arguably, they're much more pressing. Because AI is trained on human data, it inherently inherits human flaws. We absolutely have to be aware of algorithmic bias and stereotyping. For example, if an AI is trained on historical hiring data that favored men for executive roles, the mathematical prediction will just reflect that historical trend, constantly reinforcing the bias. We also have to be on guard for data tampering and cybersecurity breaches. And we have to be aware of operational model drift, which is basically when models become less accurate over time because the real world changes, but their training data stays stuck in the past. When we finally realize AI isn't some evil mastermind, but just a mathematical reflection of our own historical data, we can actually roll up our sleeves and start fixing these very real vulnerabilities. And the exact same logic applies to the incredible benefits of this technology. When we stop waiting for AI to become our overlords or our conscious best friend, we can fully appreciate the immense practical rewards of treating it as the powerful tool it actually is. AI is absolutely revolutionary for automating repetitive, tedious tasks. This frees up human beings to do the creative, complex, high-level thinking that we actually excel at. It offers lightning-fast, data-driven insights. Imagine scanning thousands of complex medical images in seconds to flag potential anomalies for a human doctor to then review. It's amazing. It offers round-the-clock availability and consistency in things like customer service, supply chain management, and even code generation. These tools are completely transforming industries right now, not by replacing human intelligence, but by supercharging it with massive computational scale. Which leaves us with this final, really critical thought. We are entering an era of what some experts are calling artificial capable intelligence, meaning systems that are highly capable of executing incredibly complex workflows, even if they don't possess a mind or a soul. The biggest lie about artificial intelligence was always that it was becoming us. But the truth is far more practical, and honestly, perhaps even more empowering. AI is a mirror. It's a calculator. It's a master predictor. It is quite literally the most sophisticated tool humanity has ever created. So the big question isn't whether AI will wake up and replace us. The question is, how will you and how will humanity leverage this incredible predictive math to shape tomorrow? Think about that next time you interact with these tools. Don't look for a ghost in the machine. Look for the patterns, understand the math, and figure out exactly how to use this ultimate tool to your advantage. Thanks so much for joining me on this explainer, and keep questioning what's under the hood.